Welcome back to G Fun Facts Online. Today, we are not just talking about a new software update or a shiny new gadget. We are dissecting a tectonic shift in the engineering world, a moment in time that industry analysts and forward-thinking CTOs are calling the 30% threshold. This isn't a buzzword. It is a mathematical and sociological tipping point that defines the exact moment where the traditional way we build software collapses, and a new paradigm, the AI-Assisted Software Lifecycle, is born. To understand the gravity of this, we have to look at the history of coding. For decades, the limiting factor in software production was the speed at which a human being could think and physically type valid syntax. A proficient senior engineer might produce 50 to 100 lines of high-quality, debugged code per day. That was the speed limit. But we have now arrived at a critical juncture where AI-generated code surpasses 30% of a repository's volume. This is the first dimension of the threshold. When AI writes the bulk of the boilerplate, the human developer transitions from a writer to an editor. And this brings us to a psychological phenomenon known as the reviewer's dilemma. It is a well-documented fact that it is significantly harder to spot a subtle bug in code you are reading than in code you wrote yourself. When you write it, you have the mental model of the logic in your head. When you read AI-generated code, you have to reverse engineer that logic. If the human editor isn't hyper-vigilant, the codebase bloats with what we call LGTM code. Looks good to me. It is syntactically correct, but structurally brittle. But the 30% threshold isn't just about volume. It is about efficiency. Early adopters of AI coding tools reported modest gains, but as tools have matured from simple autocomplete to context-aware agents, the baseline has moved. The 30% threshold now refers to the minimum efficiency gain required to simply remain competitive. If your engineering team is not delivering features 30% faster than they were 3 years ago, you are effectively operating at a loss relative to the market. This is the Jevons paradox of software. As coding becomes cheaper, the demand for code increases. Companies that cross this efficiency threshold don't fire developers. They finally tackle the massive backlog of features that were previously too expensive to build. The third dimension is the cultural tipping point. Sociological studies suggest that when 30% of a population adopts a new norm, it creates a critical mass. In software teams, once 30% of engineers are proficient with AI workflows, using retrieval-augmented generation for documentation or prompting agents for refactoring, the old way becomes visibly obsolete. The friction between AI-native developers and traditionalists becomes untenable, forcing a universal upskilling event. Now let's walk through what this actually looks like in practice, phase by phase, starting with planning and requirements. In the traditional waterfall or agile models, the requirements phase was essentially a game of telephone. Business stakeholders described a need, product managers wrote user stories, and engineers interpreted them. Misalignments were common and costly. In the new AI-assisted lifecycle, the 30% threshold manifests as a massive reduction in ambiguity. Generative AI acts as a requirement refiner. Imagine a product manager inputs a raw, messy paragraph about a new payment feature. An AI agent, trained on the company's existing architecture and business rules, immediately parses this request. It doesn't just format it into a ticket. It interrogates the manager. It asks, "You mentioned secure payments, but our current gateway supports Stripe and PayPal. Do you intend to add a new provider or stick to existing integrations?" It might point out conflicts with logic defined in other user stories. This allows for feasibility analysis at the speed of thought. Previously, a feasibility spike took a senior engineer days of research. Now, an engineer can feed requirements into an LLM with access to the codebase via vector embeddings. The AI performs a gap analysis, identifying exactly which services need to change and where the potential dragons lie in the legacy code. This results in a 30 to 50% reduction in estimation variance. We aren't guessing anymore. We are predicting based on deep structural analysis. Moving on to design and architecture. The blank page syndrome is the architect's enemy. Starting a system designed from scratch is mentally taxing and prone to availability bias, where architects stick to patterns they know. In this new world, the architect becomes a curator. Instead of drawing one system diagram, the architect prompts the AI, design a scalable microservices architecture for a real-time inventory system. Propose 3 variants: 1 optimizing for lowest latency, 1 for lowest cost on AWS, and 1 for maximum maintainability. Within seconds, the AI generates 3 distinct diagrams with infrastructure as code skeletons. The architect's job shifts from drawing boxes to analyzing trade-offs. They might mix the latency optimization of option A with the cost controls of option B. The threshold here is the volume of exploration. Architects can explore 30% more of the design space in the same amount of time. For front-end development, the leap is even more visceral. Tools like Screenshot to Code allow designers to draw a napkin sketch, photograph it, and receive a working React component in return. The friction between design pixels and working code is dissolving. Now we get to the core transformation, coding. This is where the battle for the soul of software engineering is being fought. Coding is changing from manual transmission to self-driving with hands on the wheel. We have moved past simple autocomplete. We are now in the era of the agent. An agent can be told to refactor an entire class to use the factory pattern and update all references in the project. The biggest bottleneck for this was context. If the AI didn't know about a module in another folder, it would hallucinate a new one. But with the advent of massive context windows, holding over 1 million tokens, and RAG techniques, the AI now holds the entire project in its working memory. When a developer asks about a bug causing checkout lag, the AI traces the execution path through the front end, the API layer, the middleware, and the database queries, identifying that a missing index in a SQL query is the culprit. However, this ease of generation brings a dark side: lazy code. Because generating code is so easy, developers are tempted to generate too much of it. Instead of creating a clever, reusable abstraction, it is easier to let the AI copy-paste, modify a block 10 times. This leads to code volume inflation. A system that should be 10,000 lines balloons to 15,000 lines because the AI favors verbosity. The new metric for code quality is not just complexity, but semantic density. How much value does each line of AI-generated code actually deliver? If we are generating code at superhuman speeds, we must test it at superhuman speeds. The traditional write code, write test, run test loop is too slow. The 30% threshold in QA is reached when the AI generates more test code than the humans generate production code. This sounds alarming, but it is necessary. We are moving towards self-healing tests. When a UI element changes, say a button ID shifts, traditional scripts fail. AI-driven testing agents detect the failure, analyze the DOM, realize the intent is the same, and self-correct the selector to pass the test. Furthermore, AI is revolutionizing the data used for testing. Instead of using scrubbed production data, which is a huge privacy risk, developers can ask an AI to generate a SQL script to populate the database with 10,000 users, distributed across regions, with specific churn rates and malformed addresses. The AI creates a statistically perfect synthetic dataset in seconds. Next is deployment and ops, or AI ops. The wall between development and operations is crumbling. In a traditional pipeline, if a build fails, a human reads the log. In the AI SDLC, the pipeline is active. The CI agent parses the error log, identifies a dependency version mismatch, checks the breaking changes in the library's changelog, and automatically generates a pull request to fix it. The human just gets a notification that the build failed, but the AI fixed it, and it needs a review. This extends to predictive scaling. Traditional autoscaling reacts to spikes in CPU. AI ops predicts them. By analyzing historical traffic patterns, marketing calendars, and even weather reports, the AI pre-scales the infrastructure 30 minutes before the traffic hits, eliminating cold start latency. Perhaps the biggest opportunity lies in maintenance and legacy modernization. We spend 70% of our time reading and maintaining old code. AI is the Rosetta Stone for this. Banks and insurance companies are sitting on mainframes running COBOL code from the 1980s. The engineers who wrote it are retired. AI can ingest these million-line monoliths, explain the business logic in plain English, and propose a strangulation pattern to migrate it to modern microservices. The threshold here is trust. Once the accuracy of AI translation crosses the 99.9% mark, the great migration of legacy tech will begin. So where does this leave the human? If AI plans, designs, codes, tests, and deploys, is the human obsolete? Absolutely not. But the role is unrecognizable. The value of a developer is no longer their ability to recall syntax. Their value is in their ability to reason about systems, security, and semantics. We are seeing the emergence of the AI orchestrator. This person manages a team of AI agents. They assign the front-end agent to build the UI, the back-end agent to write the API, and the QA agent to test it. They sit in the middle, resolving conflicts and providing the human taste that ensures the product feels cohesive. But there are risks. We face a junior gap. If AI writes all the simple code, how do junior developers learn? We learn by struggling with syntax. If that struggle is removed, we risk raising a generation of senior engineers who can prompt but cannot debug. There is also the risk of the hallucination supply chain. If an AI hallucinates a package name and a developer installs it, they might be installing malware created by a hacker who knew the A. I would make that mistake. This is called package hallucination squatting. And we must consider the homogenization of software. If everyone uses the same model to generate their UI, every app starts to look the same. brands will need to fight harder to inject personality into their digital products. Looking beyond the 30% threshold toward 50% or 80%, we enter the era of agentic software. We are moving from chatbots that answer questions to agents that pursue goals. In the near future, a developer will simply say, "Fix all accessibility issues in the dashboard." The agent will scan the code, run an auditor, identify errors, modify the CSS, verify the fix, and submit a pull request. The human only sees the final result. Eventually, software might stop being compiled in the traditional sense. We might move to just-in-time app generation. Instead of downloading a pre-written app, an AI builds a micro app specifically for you, for that moment, and discards it when done. The software lifecycle collapses from months to milliseconds. The conclusion is clear. The 30% threshold is not a warning, it is a reality. The velocity of creation has decoupled from the limitations of human typing speed. For organizations, the mandate is to audit your lifecycle. If you aren't using generative design or synthetic data, you are building with stone tools in the Bronze Age. For the individual developer, the message is empowering yet urgent. The AI is not coming for your job. It is coming for the drudgery of your job. It wants to take the boilerplate, the unit tests, and the legacy migrations off your plate. It offers a trade: give up the syntax and take up the system. The engineers who accept this trade will not just survive the 30% threshold. They will build the future that lies beyond it. The threshold is here. It is time to step over. Thanks for listening to G Fun Facts Online.